According to IUPAC rules, when naming a secondary amine, we need to find what is the longest hydrocarbon chain attached to the nitrogen and name it first as a primary amine that has a substituent on the nitrogen. In this case, the longest hydrocarbon chain is both ways the same length. It is 3 carbons long, so that will be a 1-propanamine. This 1-propanamine has a substituent on the nitrogen, and that is also 3 carbons long. The name for this substance will be N-propyl, indicating that the propyl group is bonded to the nitrogen 1-propanamine. In this second example, we now need to select which one is the longest hydrocarbon chain. This hydrocarbon chain is 1, 2, 3, 4, 5 carbons long. If it is an alkane, that will be the molecule of pentane, but pentane is attached to a nitrogen, so it's going to be called 1-pentanamine. This 1-pentanamine has a substituent in carbon number 2, so that is a 2-methyl-1-pentanamine, and the nitrogen has also its own substituent, an ethyl group, 2 carbons long, so that is an N-ethyl for this CH2CH3, 2-methyl for the substituent on the longest hydrocarbon chain, 1-pentanamine because this is a secondary amine and the nitrogen is attached to 2 carbons. Now we show 3 different amines that are cyclohexane with nitrogen bonded. The first one is a primary cyclohexanamine, which has 2 hydrogens left. This one is a secondary because it has the nitrogen bonded to 2 carbons, and this one is a tertiary because the nitrogen is bonded to 3 carbons. The first one is cyclohexanamine, is primary amine, is named as a alkane, dropping the E and adding the word amine. When it is the secondary one, we look for what is the name of the primary amine and then name the substituent on the nitrogen. I have only one substituent on this nitrogen, so I put N-dimethylcyclohexanamine. All of this is only one word. On the second case, the nitrogen is bonded to 2-methyl, so this is cyclohexanamine, but the nitrogen is bonded to 2-methyl, so this is N-dimethylcyclohexanamine. In this example, I want to bring the difference between N disubstituted on the nitrogen, cyclohexanamine, and to 2-dimethylcyclohexanamine. These are 2 completely different substances. This one is a primary amine and this one is a tertiary amine. This one has higher capability for hydrogen bonds because it has a hydrogen bond donor and also hydrogen bond acceptor. As a tertiary amine, this one can form a quaternary ammonium salt when it reacts with an alkyl halide. Now we need to practice the nomenclature of some aromatic amine. This is the molecule of aniline, which was part of our chapter of benzene and derivatives of benzene. We have the amino group attached to a benzene aromatic ring, not to be confused with the aliphatic cyclohexanamine. When we have a second substituent in this benzene aromatic ring, we will consider that as a derivative of aniline. We remember the different positions, and that is when it is position between carbon 1 and 2, that will be called ortho or 2-methyl aniline. If it is on carbon number 3, this is carbon 1 because it's where the amino group is at, that will be either a meta or 3-methyl aniline. We also have the position para, which is 4 carbons away from the amino group, so we can call this 4-methyl aniline or para-aniline. Now we can compare primary aromatic amine with secondary aromatic amine and tertiary aromatic amine. All of them will be derivatives of aniline. So this is aniline in black. All of these are aniline. They have different position and different substituents. The first one is the primary, is 4-methyl-aniline. Second one is a secondary amine because it has one substituent on the nitrogen. So this one is a N-methyl-aniline. Look at the difference between 4-methyl-aniline and N-methyl-aniline. We also have one that has two methyl group substituents, and these ones are in carbon number 3 and 5, 3,5-dimethyl-aniline, not to be confused with the tertiary amine N-dimethylaniline.